Section 5.3, rates of change and slope. So we know that the rate of change is the ratio of the change in the y values to the change in the x values. And one way we can think about this is that it is the ratio of the change in the dependent variables over the independent variables. So I have a table here that shows the balance of a bank account on different days of the month. So on the first day, their balance was 550, on the sixth day, 285, and so on. Question is, during which time interval did the balance decrease at the greatest rate? So remember that we're making a ratio of the dependent variable over the independent variable. And in this case, the day of the month is the independent variable. And the balance is the dependent. So we're going to take the difference, 285 minus 550 over 6 minus 1. And we're going to calculate that out. Can I get my calculator out here? 285 minus 550 is a negative 265 over 5. We're going to divide that by 5, and we get a negative 53. And we're going to do that for each of these points. We don't know whether or not this is a constant rate of change or not, so we have to calculate out each one and decide after we do that whether or not it is a constant rate of change. So 210 minus 285 is a negative 75. 16 minus 6 is 10, so negative 75 divided by a negative 10 is a negative 0.75. 210 minus 210 over 22 minus 16, that's going to be 0 because the numerator is 0. And then 175 minus 210 over 30 minus 22. What can you say just in general about this bank account? Well, as you look at it, as you go down throughout the month, the amount of money in the account keeps going down. So that would say that they are not putting any deposits into that account. So we now have our rates of change between the 5 different points. Because there's 5 points, we're going to have 4 different rates of change. You can see that those rates of change are not consistent. So it's not a linear graph. It's just going to be kind of an up and a down. It's a broken line graph is what we refer to that as. And the question is, during which time interval did the balance decrease at the greatest rate? And that time interval is this first to the 6th day of the month. That is the time interval where we saw the biggest decrease. So if we were to have a rate of change that was consistent over the whole graph, then that rate of change is the same thing as the slope. So we're not talking 2 different processes. It's just a matter of whether or not we get a constant rate of change. So if we're given a graph and we want to find out what the rate of change is on that graph, we're going to look at the rise and the run from 2 points on the line. Now, it's going to be important to pick 2 points that cross at hash marks. So for my diagrams here, we're not going to be, I'm going to give you the points we're going to go from that cross at the hash marks, but sometimes it's hard to see what those points are when we're looking at our graph and trying to figure out, well, does that cross there? Does that cross there? You take your best guess. So I'm going to give you the points, -3, 5, and 4, -1. And when we look at this line that connects those 2 points, the first thing that should be running through your mind is that the slope of this line should be negative when I calculate it out. If I don't get a negative number in the end, then I've done something wrong. That's just one of your checks that you're going to be doing in your own mind. So it's a negative slope. So how do I calculate it? Well, -1 minus 5. I took my 2 y coordinates, put them up on top, and I took the difference between them. I'm going to do the same thing with my x coordinates, but I'm going to make sure that if I started with this point here, I'm going to start with that x value that comes from that point. So negative or 4 minus a -3. So the top we get -1 minus 5, which is -6. On the bottom we get 4 minus a -3, so that's going to be 4 plus 3, which is 7. So our slope is -6/7. Now, I said we could look at rise and run. So when we look at the rise here, we're not really looking at a rise, we're looking at a fall. And what we're going to do is just drop down horizontally until we get to that same level that that other point is on. And then once we do that, we're going to draw a line over horizontally to that point. This run that we have here, 1, 2, 3, 4, 5, 6, 7, and our rise, which was actually a fall of 6. And because it's a fall, we're going to indicate the rise as a -6. And we can see that no matter which way we do this, whether we use the coordinates of the point or we use the rise over the run, we're going to get the slope or the constant rate of change of -6/7. Now, what happens when we have special lines? Well, our 2 special lines that we have are a horizontal line and a vertical line. So here's my axis. And I'm going to put in a horizontal line at -2. Now I know one point right here where it crosses, and that point is 0, -2. I can pick anywhere else on that line and find another point. And let's just say that that other point occurs at 5, -2. When we have this, we set up our rise and our run. Our rise is equal to 0. Our run is equal to 5. So when I make a ratio out of that, I have 0 divided by 5. That gives me a slope of 0. And if I have a vertical line, I make this one at +3. We know that this point right here is 3, 0. And I'm going to pick another point on the y-axis right there. And that point is 3, 5. Now my rise for those 2 points are 5. My run is 0. 5 divided by 0, when I go to my calculator, will give me an error because you can't divide by 0. So in this case, our slope is undefined. Another way to think about this is when you're walking on the horizontal, you don't exert any extra effort to walk on a horizontal, so you have 0 for the slope. If you're trying to climb a vertical cliff, that takes a lot of effort, and unless you have some special tools, you won't be able to do it, so the slope is undefined. When we look at a line, maybe we go back up here and look at a line like this. This slope is going to be positive. Another line, this slope is going to be positive. This one is going to have a smaller slope than this one. And it's because that this line is steeper than this one, so the slope is going to be larger. But they're both positive. You need to make sure that when you're doing your work, check out your line that you're graphing and see if the sign of the slope that you're calculating is truly the sign that it should be based on your graph. So that's all there is to this section.